All right, I think we are live. I'm not sure how many people are there. I will not check because it's gonna distract me a lot, like last time. So if you are there, if you'd like to be part of this, which is gonna be awesome if you do, send a chat message. I'll keep my eye on the chat messages as much as possible. Right, so continuing from last time. Last time what we did is we talked about what KEDA is, how it works. We drew some diagrams on the whiteboard. Explained what? I don't want to manage my channel from here. Thank you so much. This is the first contribution. Jason is saying, don't rename the folder again. We will come to that, absolutely. Yeah, so we talked about what KEDA is. We talked about how it creates the HPA, the horizontal autoscalers in Kubernetes, and how it interacts with them, and the reason why we need KEDA, because the HPA built-in ones, they don't deal with external effects coming from outside affecting our scalability. So we needed something like a metric server to take that part of Kubernetes, and this is where KEDA came in. Then what we did is that we put the source code, we tried to build it. When we tried to build it, we had an error. The build failed several times. Let me take you through from there and continue from where we have stopped. So let's see. Right, so let me clear this. We had the source code. For some reason, because I was playing with KEDA like in different directories, I have KEDA and I have KEDA temp and I have KEDA core and I have like trying several things at different times. What happened is that I renamed the folder from KEDA to KEDA Ishi, I remember, or something like this. When I did that, let's open the code and see what happened then. Let me close all these. We are going to open the makefile. The makefile have different tasks. The task that we use to build is called build. Surprise, surprise. And then it builds the controller and the adapter. Because KEDA embraced the operator model, like the Kubernetes operators. It uses the operator SDK to build KEDA itself for the controller, the one that's the operator, and the adapter, which acts as the metric server. So in our build, we build the controller like we said, and we build the adapter. The trick was here. This guy, without providing any parameters, this is an SDK that we need to install on our machine in order to build a Kubernetes operator. I took you to the website the other day, Kubernetes operators, and this is where the operators are, where there's smart deployments of applications in Kubernetes. In order to build an operator, there's a lot of churn and work and code. So the guys behind the operators created an operator SDK with an operator CLI that you can use to build your operator. Now, if you build the operator, if you invoke the build as is, when I checked the code after we stuck last time, if you don't provide the argument or the name of the output you desire the build to be, compared to go build here, and you see that you can specify the output. Here we are not specifying any parameters. So behind the scenes, this invokes the Go compiler, and it does not provide an output parameter. If you don't, what happens is that it creates the package by the name of the existing folder. So I kept creating a package with the name KEDA-EASHI. Like, I had no idea where that came from because I was so involved in the streaming. I was like, too distracting. And the package was wrong. So when the operator SDK is invoked, it also tries to I put this, I think, this is the latest version. We added this one. What I want to say, I forgot. So we build it without this parameter. So it picks up the folder name and creates a package with the folder name. And then, yes, I was talking about the Docker, because after this it builds the image that we want to create. So if I open the Docker file for the adapter, was it the adapter? I think. No, it wasn't the adapter, the controller. Docker file. You'll see that it's expecting that the package name is KEDA. And in our case, it was KEDA-EASHI. Hence, the build failed. Anyway, what I did is that I changed the make file. Let me hold this here. Make file. I added the output to be explicit about the name, and then I pushed this to KEDA, and the pull request was accepted. Luckily, I didn't break anything else. Cool. Now, continuing from here, what we need to do is to build a KEDA operator through the build from our source code and deploy KEDA to our local cluster and run it based on the examples and make sure that it's run properly. This way, like, I like to take any development in basic stages, because if I download the code, I change something right now, and I try to build and deploy, I will always be suspicious about what went wrong. Was it my code? Was it something else? But if I go with the basic blocks as much as possible and build accordingly, once I change something, I know, like, it was that change. I hope that makes sense and you agree with me. Cool. All right, so let's do that. We have the source code this time. Now, if I build without any parameters, like this, if I build like this, what happens is that in our make file, we have, this is the top of the file, we are creating variables, and we are using these variables in our build. You can see that there's an image tag, Woohoo! It's 1.0. Congratulations, Microsoft and the guys and the team and the open source guys. You're brilliant. You made it. You're awesome. It's released. So image tag, the image registry, and the name of the repository of the container. These are the main variables. If you check the image controller, you'll see that it's the construction of these. So you'll see that it's docker.io slash KEDA core slash KEDA colon 1.0.0. So if I continue with this and I build without supplying any parameters, I'm expecting that I will have an image built for me for these two containers, for these two Docker files. Let's see. For the adapter, we are explicitly invoking the Docker build. In the controller, we are building the package internally. So before we do Docker build, I'm on minikube. I'm gonna list all the images I have. Please, if you have any questions or comments, ping on the chat. The fun part is being interactive. So you can see that when I list the packages, I don't have anything that is KEDA. Now, if I make build and I don't screw up, let's see what happens. I have the output explicitly set to KEDA this time, and I'm hoping that I'll be lucky enough that everything will work fine. Awesome. No errors this time. Docker images, and you can see that we have this image, the KEDA, this is the operator itself, and the metrics adapter that is part of KEDA, that it works as the metric server within Kubernetes. Successful. Now we want to deploy these two containers to our cluster and deploy all the required things to make KEDA work properly. Because these containers, of course, are not the only objects that we need to create. So, what to do? In my way to home, preparing for the stream, I was looking at the source code, and I knew before that we had charts folder based on Helm, because the first time we created the first time KEDA, or in the early stages when KEDA was there, we had let me show you in code maybe. Oops. What did I do? In code. If you check, where's my mouse? If you check here, and we close everything, there used to be a folder called charts. But before we talk about Helm and charts, we had deploy. Deploy is a folder where we have all of the objects that are required to create a KEDA environment. So we have API service. We have, this is for the metrics server, we have the operator, close this down a minute. The KEDA operator. This wasn't the operator before, it was a normal controller, but it's changed to the operator. We have role bindings. I hope I don't screw up with the role bindings because I'm not sure if my minikube has role bindings enabled. We have the role, the cluster role. We have the service account that's gonna run the operator, and we have the service that's gonna be the service for the operator. Now, there's also what we call CRDs, custom. Oh, I forgot the abbreviation. Custom resource description, I think. The CRDs, we have the scaled objects. The scaled objects are the objects that we create to describe what triggers the scaling based on the scalars that we have in KEDA, and we configure the scaling, like how much we want it to be scaling based on what value, the target value, and also the container that needs to be scaled. Yeah, we create these scaled objects once we want to run a container that can be scaled based on events. These files are the files that create the custom objects. The operator will be listening to any object that is created based on these schemas, if I can call them schemas. But is my chat stopped or it's not a good idea to do this. Let me just make sure, because I remember that the chat stopped for my friend David yesterday. So I'm just gonna keep this here. Right, so this is the scaled object definition. We have the triggered authentications. This one, at early stages of KEDA, once you create an object of these, what happened is that you would put your secrets and authentication authentication keys within the scaled object itself. That caused a problem because your secrets are outside. So the guys decided to move the authentication out of the scaled object to be on a different object that uses the secrets and all the environment variables, and then we use the reference to these triggered authentication objects within the scaled object. There is oh yeah, these are the alphas of this one. So these are the files that we would awesome, you're most welcome, guys. Amal and Jason. So these are the files that we use to deploy. Now at some stage KEDA moved from normal deployment script, because every time you wanted to deploy, you would go to these files and explicitly change whatever you want to change, like the replicas, the operator name, whatever, or the tag, and this was not nice. So of course everybody is embracing Helm. There was a folder that used to like called charts, where we have all the Helm charts that template the deployment files for us, and then you can use Helm to install, or if I can use the word install or deploy KEDA to your cluster, and manage it and delete it and all the nice things. Surprisingly, in my way preparing for the stream, the charts folder disappeared. I panicked for a moment. Actually, it was longer than a moment. I panicked a lot because we will not be able to deploy if we don't have the charts. Or we can use the deploy folder, but it's gonna be ugly. I'll be changing values and the files will be checked out and stuff. So I realized that the charts were moved to another repository. So we have the GitHub, KEDA core, KEDA repository under the same organization. There is the charts, and then we can use these charts to create our KEDA. I have mixed feelings about the separation, but it's we can try it and see how it goes. There is a possibility that things might fail because I'm not that awesome, and we'll see how it goes. So now that we have built KEDA, again, look at our images just to make sure that we have the right things. Now we can use Helm, which is in another repository, to deploy KEDA. If I, in my cluster, show you git all namespaces, I'll show you here that we don't have any KEDA installations so far. Yeah, we don't have like no pods, no services, no deployments, no replica sets, nothing. And if I do Helm list, I don't have any Helm charts installed. Right, so we want to install our local image from the Helm charts. So if we go to the, do I have it open? I don't. Let's open, because I cloned the chart repository before I started. Okay, so this is get the charts, and we have the charts repository. I learned my lesson. I renamed the root folder and then clone within it and don't change the name. CD charts, and then we have all these things. There's documentations and README. We don't have to do this. We open KEDA itself, and here we go. This is where we have the charts. Let's open it with code. If I expand this and then squeeze this up to here, we'll see that we have a chart. This is the definition of the chart, and then you'll see the values. So if you are familiar with if you're not familiar with Helm, think of it as these are the templates where you have the mustache like placeholders. With any template engine you have a template and you have values, and you supply the template and the values to the engine, and it spits out a generated something. Yeah, in our case it's the deployment scripts, and Helm can use these deployment scripts to install stuff. I think this is the same, if I'm not wrong, the same as the Hugo template engine, which is the Go really template engine. So if you check the values, you'll see that we have an operator name. We have the image. This is a very important variable where we are specifying which images to be deployed or used to run the templates installation. So I'm gonna let me just continue with these three, and then we'll come back to tell you where this is. We have the KEDA, we have, which is the controller, the operator, we have the metrics adapter, and we have the pull policy. The pull policy, this is also one of the most important things, is that when you set it to always, once you install any or you deploy any container to Kubernetes, with this flag, Kubernetes will always, because you deploy the script, you create the objects or the definition and stuff, and then Kubernetes, okay, I need to pull these images from the repositories. And when it does, if this flag is always, it will always pull the images from the repository to the node or to the pod, and then instantiate that container from there. If you the default repository of Kubernetes to pull images from is Docker Hub. This means that once you deploy, if your image is built locally, you deploy with this flag, pull policy, and then Kubernetes will say, okay, I have to pull it from the repository, which is the default one, which is dockerhub.io. It will try to pull the image, it will not find it, or it will find it if it matches the tags, and it will download it, and then install it. So if you create a local image with a specific tag or a different name, and you have this flag, you'll never deploy. You'll never be able to deploy. We will change this in a minute, I'll show you how. But before we do that, let me show you the templates. So you can see that there is a matching template files for in the deploy folder for this. So if we open, for example, the operator one, you'll see that these values come from the values file. So values.operator name, it's going to be values operator name. It will be replaced here. And you can take all of this with you. So this means if we create an operator with a different name, we have to make sure that we change this in the values. So you can change the values of the values. You can change the values of the values in the file, or you can override them when you invoke the command. So in our case, because we didn't change any tags, so if I clear this, Docker images, Docker image is, you'll see that I didn't change the tag this time, which is, it's a little bit not too good in our test, because if I make a mistake and I specify, I don't override the always, it will not use the image I created right now, it will use the one from the internet, and because they are matching the tag, it's gonna work, I think. Unless, no, you know what, I don't think it's gonna work, because I'll show you how, I'll show you why. Alright, so, back to the point. We need to pull these images, pull these images. Now, in the documentation that I used before, I think it was in Kubernetes, sorry, in KEDA, I said KEDA. If I open the README file, readme.md in the root, and we change this to the preview and scroll down, we will see that we can use this command to install the Helm chart. By the way, we can use the development container to build KEDA locally awesome contribution from awesome guy, but as I was worried about my my progress, so maybe next time we come back to this, because using this is awesome. Really, I don't need to install operator SDK on my machine or whatever. It's gonna just work within the container. We'll come back to this, but coming back to this documentation is not up to date because we don't have the charts folder, because it's moved. But anyway, we can copy it. We can copy it and go back and move. No, this is KEDA. We want to go to the chart. We are in the right folder. So if I paste this, let's see what we have. We say Helm install the chart in this folder, and then set, well, this is where we override the values. Image.repository. This was true before, but it's not true anymore, because if we check the documentation, sorry, not documentation, if we check the charts again, we will see that we have image, that's good. We have the image, but then we don't have a sub repository. You can see that this is YAML, and there's a space here or tab, so be careful. So this is image.KEDA or the adapter or pull policy. So the documentation is all, be careful. So we don't have the repository here. What we need to do is change this, remove this part. Oh, I can't remove it like this. Remove the repository and take this part, but this part also includes the repo, and we don't want to include the repo because our image does not include the repo here. We have KEDA core, KEDA. See, if I copy this and we say delete until we reach to the column, comma, KEDA core, but if we don't supply the tag, it's going to be the default, which is wrong. So we are going to say tag 1. There's an extra dot here. Oh, image.KEDA. Image.KEDA is this. We have also to supply another variable, which is the metric adapter. So because it's still under the image, we are going to say image.metrics adapter equals, oops, I already copied that. It's very smart here. I should paste what I've copied because we are going to make sure that we don't fail in this one. So the image metrics adapter equals, again, we take our friend here and then paste. Also, we need to put the tag. That's cool. Now, this is the tricky one. Image pull policy, we change it from always to if not present. This means because we are using minikube and we have the image register that we already have the image within. Kubernetes will check within the nodes and the pods, and if the image exists, it will use it. So when will it pull from the internet? If the image is not present. And I think this dot is extra. Right, so if we do this, let's see if we don't have anything explode in our face. Did it work? I think that was easy. Should I clear? This is the installation. So if I helm list, we have a deployment here. Let's get the pods. No, pods. Let's get everything. Get all namespaces. Did it work? Yeah, awesome. So we have in the pods, we have one, you know what I'm trying to say, yeah? We have one pod with 2 runnings. Yeah. We have service for the KEDA operator. We have a service for the metrics. We have, I think what doesn't show here is that we have CRD. So if I say custom resource definition, we will have a scaled object, and we have triggered authentication. So once we create any object of these, the operator will be listening and will create all the required stuff. Right. So now we have KEDA running in our cluster, but we don't have any containers to test. Let's open the example. What time is it? Are we on track? Yeah, okay, fair enough. Let's open one of the examples of what? Examples of scalars. Is this SCADA? Yeah. I think the guys move the examples from here to another repo as well. So if we go to KEDA core, I think we can move from here. And I think it's sample go RabbitMQ. Alright, now the sample is making me worry a little bit. It worked for me before, but because we are on masters now, sorry, master, not masters. We are on master and we are on the bleeding edge. Let's see if this example works. I think I cloned this before. You know what? Even maybe on the same cluster. Okay, get all namespaces. Do we have anything for RabbitMQ? We don't. Cool. Okay, so let's start from scratch. This is awesome. This is awesome for everyone, I think. Right, so let's do this. We already have this cloned, I think. Let me check. Let me open new one. CD source. It's not KEDA. KEDA core. Yes, here we go. We have a sample go RabbitMQ. So CD sample. See, what did I do here? Get diff. Yeah, this is one of the things that has changed. Maybe I will commit this change and start on a clean slate. All right, so just to take you in what I was trying to do. This is which file, the deploy consumer. All right, so in the example, let me take you through the example first, and then we'll see. In this example, we will first install a RabbitMQ chart for a RabbitMQ server within our cluster. Yeah. So we have a RabbitMQ running. Then what we will do is that we will deploy a RabbitMQ consumer. I'll show you the chart in a minute. I can show you from here. Deploy consumer. This is a pod or a container or a deployment where we RabbitMQ is a queue system where you throw messages on the queue, and then you have a publisher that pushes messages to the queue, and then a consumer that consumes the messages. Now, in this example, we're looking at the consumer one. If the publisher publishes a lot of messages, we want to be able to put a lot of consumers to follow up on the messages that are expanded in the queue. So there is a KEDA scaler that called RabbitMQ scaler that looks, based on the configuration, it looks at the queue, monitors its length. If the length is too much, it will scale the pods that are consuming. If the queue is small, then we will remove the pods that are consuming. So this one is the consumer, and then we have the publisher. The publisher just publishes the messages. Right? So in the consumer, you will see that nothing. You will see that it's just a normal consumer. All right. This is the bit, the scaled object. My change was to make the old code is exactly like this. So the host used to be embedded. So the connection string, I think this connection string, is it? I think it's this guy. It used to be plain within the RabbitMQ within here. So what the guys did is that they removed from here, and they changed KEDA so that KEDA can say, all right, the host is coming from somewhere. It's either environment variable or it's a secret. It's matching the name. So RabbitMQ host or RabbitMQ host. In my case, I put it in environment variable just so that I can survive. Yeah. This is the change I made. All right. So let me add git commit. Put the host in environment variable. Of course, we're not gonna push. And then git git branch. Let's create a branch on this commit for us. Git branch. I don't need to check it out. So I say git branch. A local environment variable. I don't know. I hope this is a good name. So if I say git k, I'll see that we have the right branch created. Now, if I say git k, this is some of the git trickery. Git fetch, okay? Git fetch everything. Let's bring all the branches from all the remote. We have git remote -v. Let's see. I have two remotes, my fork and KEDA's. What I will do is I will update my local master to matches KEDA's, because I'm hoping that it's up to date with the latest version that we are looking at, and then update my fork master based on that. There's several ways we can do this, but I can say git k minus all. Let's see what's happening. I will reset my master to EARChy master. Oh no, I can reset my master directly to origin master. I think this is what I'm gonna do, and I don't care about my my remote, my fork. I think I pushed something sometime before. Yeah, it was me. Don't do that. Don't push to your master fork. Always, if you are contributing to open source, at least this is my way. I create a branch. I'm happy with it. I create a pull request to the remote repository that I'm contributing to. They pull it to master. Everything is fine. I merge back to my master, and then everything is fine. If I push to my master, it's not nice. All right, so if I git reset my master to origin master, what happens? I have two files change. I will git check out dot. So I'm ignoring my changes because it kept it in my workspace. If I git k minus all now, I will see that my local master is matching KEDA's origin master. Awesome. Cool. All of this to make sure that we have the right repo, because we have this awesome trickery. Now back to how we can follow up on this guide. I hope I didn't lose anyone so far. Now, what will we do? We want to install the RabbitMQ Shouldn't GitHub have a copy? It would be a nice feature. Let's install I don't think Docker will work here. Remember, because I'm using minikube and I also use Docker, so I want to make sure that my Docker CLI is configured to connect to the Docker daemon in my minikube. I have to, every time I create a new tab, not every, like most of the times, I need to make sure that, so if I work Docker images, see, I fell in that trap before. So, you know what, the microphone is really far, I just realized. Let's see if, not in the picture, not in the picture, not in the picture. Oh, in the picture. Cool. Maybe this will enhance the quality. So if I say evaluate this expression minikube to Docker environment, this command will export the environment variables to configure the Docker CLI to talk to the Docker daemon in there. So if I do that and Docker images, now we are good. So if I paste this, we are installing the RabbitMQ server with the basic configurations. Let's see if this works. All right, seems to be working. Clear. Docker git pods. We have RabbitMQ still container creating. -w, like it means watch, usually updates that's running. Yeah, cool. Now we are awesome. Control C, continue to the example. kubectl git pod, we just did that. Now let's create the consumer. Are we on the right folder? List. So if I do this, yeah, we have created a consumer. I think in the guide we need to check that it's running before we deploy the publisher. Well, this is weird. We deployed the consumer created, deployment created. Oh, okay. So what should I do? Okay, git deploy. Yeah, we have the consumer. Yeah. This is one of the nice parts about KEDA, is that KEDA in Kubernetes, if with the autoscalers, you have to have at least one instance running, and it scales it from 1 to a lot and from a lot to 1, but it does not do from 1 to 0 and from 0 to 1. This is where we show that KEDA comes in and can solve this problem for us. It scales from 0 to 1 and from 1 to 0, but once it wants to scale from 1 to many, it can do this through the horizontal pod autoscaler in Kubernetes through the metrics server. It's like a bit of a dance. Right, so where are we? Yeah, let's continue. Now we need to publish. We publish, and then instantly we see how many deployments we are having. Here you go. It's working. The nice thing about this, because if you are familiar with KEDA, you probably have seen this example before. Why I'm happy about this right now is that this is our local KEDA. This is that we have built right now. We will remove the images that we have created because we're going to create new tags, or maybe we don't have to, but it's like, no, we have to. We remove KEDA from the cluster, and we create another KEDA tagged with our name, and then we start trying to create a scalar from there. Alright, so it's been an hour just in preparations for what we are going to do. We might not be able to finish everything today, so we might wrap up at some point, maybe within half an hour. If you like me to continue, maybe ping me on the chat. If anyone's still there, if you have enough, maybe we can continue in next week. Now you can see that KEDA is managing the scaling because we have a lot of queues, a lot of messages, and it's being consumed and calculating and stuff. Now that we have ran the basic example, what we will do is take you through the code of a normal scalar and show you how it's created. you can see now that the messages are all consumed. We had this many instances or pods, and then once the messages are all consumed, you can see that we jump down to 0. Right, so the best way to write a scalar, so this is this the charts? Yeah, this is the chart. Let's close this. Thank you so much. Oops, I closed everything. Yeah, this is one of the things I don't like about Mac OS. Closing the window, closing the app. Annoying. Alright, so open recent. Oops, oh, this is already open. Open recent. KEDA. Is this right folder? I'm hoping so. No breadcrumbs? I'm hoping so. Okay. Now, let's close this and this and this. And let's explore the folders. Build, this is where we split the output and where we have the Docker files that create the operator and adapter. I don't want to go through all the details of KEDA because it's complicated and not complicated. It's complicated. I only spend time understanding the scalars themselves, not too much inside KEDA. So there's some things I will just skip. But this is where the entry point, I think, for KEDA and for the operator itself. The deployment, the distribution, examples, hack. I think this is to make a deep copy of the classes. Can I say classes in Golang? I don't think I can. I'm not expert, hopefully yet. Package. This is where the fun stuff is. We have the controller. This is where we have the scaled object controller that looks after the scaled object and monitors it. We have the handler. This is where the scale handler works, where it tries to get the metrics and see what needs to be done to be scaled out, scaled in, etc. And the provider, this is, I think the provider is the adapter, where that once you install or deploy to Kubernetes and configure Kubernetes to use it, it will use it as the metrics server to query the metrics. And now this is the fun stuff. You can see all these scalars that are part of the binary of KEDA. You can see that the guys created an amazing effort in trying to create as many scalars as possible. We have AWS CloudWatch scalar, SQS, AWS SQS scalar. This monitors the queues of AWS. Azure Event Hub, Azure Queue, very simple and straightforward. Kafka, RabbitMQ, and other stuff. Now, before we continue, let me explain one thing, which is at the beginning of KEDA as well, the only way that you can create a scalar is by contributing to the code directly. So you clone KEDA, you create your scalar, you submit a pull request. Jeff, Ahmed, and the guys will have a look at the pull request and say, oh yeah, it makes sense. We want this scalar to be part of KEDA. Then merge it in, reiterate on it, and it becomes part of KEDA. If you wanted to create a KEDA scalar for yourself on a specific way, which we are planning to create with the coming streams, if you want to create one for yourself, you have to deploy your own KEDA, just like we are doing. And this is not really good. Once you fork a code base and you expand on it, and you have to merge back if something like a fix that they have created, and it's a big dance. So after some time, the guys created something called external scalars. External scalars are pods that you deploy and you configure with your KEDA, so that they communicate with KEDA external scalar communicator or whatever through gRPC, and it will be some sort like it will get the metrics and the information from this external scalar. So this means that you don't have to change KEDA. You just deploy KEDA, and you deploy your external scalar on a different, from a different deployment, different binaries. You can even write it in .NET Core, I think. And then the dance will happen between KEDA and your external scalar. In our stream, I'd love to I want to start with the one that is really that has been there for a while, which is scalars within the binaries. They are a little bit straightforward, where you don't have to juggle with the gRPC stuff, and it's less error prone for us, and it can build the basic grounds for what a scalar is and how it's built. And then we can, maybe in the future streams, we can look at using the external scalars, and by that time it's going to be super awesome. Right, now if we pick an the simplest example of a scalar to see how we can create this create one, I think my looking at these things, I think the simplest one was the Azure Queue or the RabbitMQ. Let's check the RabbitMQ and see if we can make sense out of it. If we don't, maybe we can fall back to Azure if necessary. Alright, so you can see that in the packages we have in the package we have the scalars, and you can see that there is a file before we go to the queue. There's a file called scalar. If you're not familiar with Go, you can create an interface, and once this interface has these methods, whatever struct that have methods identified for it that match these methods, then instantly that struct is considered implementing that interface. You don't have to explicitly, like .NET, to say this class implements that interface. Scalar is the object or the interface that is dealt within KEDA itself. We'll come to the details in a bit. This is how it creates an abstraction over your scalar, and it can use your scalar once you create it and deploy it. So there are 4 methods that your scalar has to implement in order for it to work properly with KEDA. The first one is the simplest one. Get metrics. Get metrics will always be invoked, will be invoked periodically, periodically, will be invoked from either the scale handler within KEDA, if it's between 0 and 1, or from the horizontal put autoscaler through KEDA to this one to retrieve the metrics. We will talk a little bit more about the metrics and how they work in a bit. So, you know what? Maybe we should do this. Let me just explain, continue explanation, and then we come to the details on how the formula works. Get metrics. It gets a context through which you can, I don't know, it's like the context that is being run within the KEDA. I think at this point context here is past nothing, so we are not really utilizing it in any of the scalars I've checked. The metric name, so in our case, for example, is the RabbitMQ. This might be a little bit confusing because we are already a RabbitMQ scalar, for example. Why do I need to send a metric name? In case we have multiple metrics within the scalar itself. And then the selector, if you have another level of criteria within that selector, and then we retain an external metric value. The external metric value, if we go to the definition, you'll see that we have a type meta, we have the metric name, we have the metric labels, a timestamp. When we read these metrics, the timestamp that we read these metrics at, because it needs to be evolving. Window seconds. To be frank, I haven't really paid a lot of details on what window seconds is, because I didn't really need. Maybe I should at some point. And then the quantity. The quantity is the bit that we need to explain a little bit more. Now, this is where it can be very confusing. It confused me a lot, and it might confuse you. I'm sure you're smarter than I am. Let's try the whiteboard, shall we? I don't know if it's gonna work, but we can try. Whiteboard, and then we open Firefox and clear the canvas. Clear the canvas. Ah, okay. Metrics usually is a value against time. So if we have time here, a metrics would say like the metrics we are reading is 10, 20, 5, 40, 30. It's a continuous measurement of something. It makes sense in CPU, it makes sense in RAM, because it's a continuous measure of something that's happening over time. In our case, for example, if we are looking at RabbitMQ, the metrics that I think it's not a good smart idea too. So if I clear again, in our case, if we are looking at the metrics of the RabbitMQ, it's the size of the queue. Yeah. So at one point it can be 30, and then can be 100 items in the queue, and then it can come back to 20, yeah, 30, 100, 20, and etc. This is the value that we retain with the quantity. Okay, now this is we have explained the Git metrics, where we'll take an example with the RabbitMQ for further details. Git metrics for scaling. The Git metrics for scaling is once you create a scaled object that if I open the scaled object, so if I let's open. Do we have it open? We don't have code. Let's open this folder. If we open this, if we open the deploy consumer, you will see that we are creating a scaled object. Yeah, we are configuring KEDA, or we are creating a scaled object that will let KEDA know that we need to there's a deployment that needs to be scaled based on RabbitMQ, the trigger, with this configuration. The Git metrics for scaling constructs, or it retains some of this information to create the horizontal pod autoscaler within Kubernetes that will use this information to query the metrics server within KEDA to get the metrics. Yeah, so it's like it gives a cheat sheet to Kubernetes. Like, this is what you need to query me to know if you need to scale or not, and then you'll query me. I'll give you the metrics when you ask me. But this is the establishment of the horizontal pod autoscaler. Is active is a flag that sometimes the scaler themselves within KEDA they need to die. For example, like the resource or the service that they are using is dead. It does not make sense to be retrieved, or like this, or maybe based on a configuration that we need to disable the scaler for that trigger. Is active returns true or false, and based on that, KEDA and KEDA will just return like there's no metrics. It's dead. For example, the scaler is not really working. Clause, because scalers will consume resources out of the cluster most likely. Like it will make connection strings to connect to Azure or RabbitMQ or the SQS. It will create resources. Clause is we're given the chance to discard these resources and make sure that they're closed and connected. And disconnected. These are the 4 things that need to be in a scaler to be able to work properly. Now, things that I need to highlight here is that in the scaled object that will be created to scale, you can see that we are giving it the deployment that we need to scale based on the metrics. Sorry, this is the target. Yeah, this is just a label. This is the target that we are the deployment target that we need to scale out. The polling interval is how often we need to pull for the metrics. The cooling down period is how long we need to wait until we scale down or change the scale. The max replica count, like you definitely don't want to exhaust your cluster based on the scale deployments. You want to have a max number of RabbitMQ consumers. The trigger, this is how KEDA knows which scale needs to be invoked and used to get the metrics to retrieve the metrics, because we have, like I said, we showed you that we have a lot of metrics here. How does KEDA know which one it should invoke to get the metrics for that scaled object? Through this one. And then these are the metadata configurations for the RabbitMQ that it will use, connection strings or whatever, to be able to connect to RabbitMQ or Azure or SQS. I hope this explains things properly. Now we have 50 minutes. I think I'm trialing with the stream. I don't know how long a stream is good. I've seen people do 6 hours. I've seen people do 1 hour. I'll try to make it 1 hour and a half, because it's a stream. It's not an educational video. Otherwise, it would have been 10 minutes. Any feedback from you would be awesome. On the speed of things, on if it's interesting, it's not interesting. Is the 1 hour and a half is too long? If we should make it shorter. Your feedback would be awesome. Let me wrap today by showing you RabbitMQ, so that I know probably you had hopes that we would start writing the scaler today, but there was a lot of explanation. I promise next week we will start from where we ended it, so we're not gonna spend a lot of time going about. So let's check the RabbitMQ scaler. You'll see that we have the struct for the scaler. This is where we are going to define our 4 methods against, so that KEDA can figure it out and use it as a scaler through the interface. Where in the struct we have metadata for the RabbitMQ. We're gonna come. Sorry, we're gonna come back to it. It's just down here. The connection and the channel. Come back to these. In the metadata, we have the queue name based on the scale objects. The queue name that we are trying to query, the host name or the host, the connection string and all this that constructed from the scale object to communicate, and queue length. Now this is where the bit part. I'm gonna come back to how we have created the or how the RabbitMQ has the different 4 methods to be used within KEDA. But before that, let's talk about how is this created. Every scaler has to have a constructor. I still like I'm sorry if I'm offending any Golang program out there. I come from a .NET background. We call it constructor. So this is a method where we create the scaler itself. This will be invoked by KEDA. Well, I'll show you where in a bit. But it receives a result environment variables, like a map of all the keys and values for the environment variables that are running within that deployment. The metadata that are already parsed from KEDA does this for you. It parses the scale object, put it in a map and supplies it for you. The authorization params, it does the same for the authorization params from the authorization trigger scaled object. And by the end of this, we are expected to get a scalar. You can see that it's the interface that we are using to retain, but we are really retaining the RabbitMQ scalar. We parse the metadata that we have received. We make sure that everything is fine. We create a connection. We put the connection in the object. So we construct the scalar itself. We put the metadata within. We use the connection as a property within that object, and then we retain that object. Now let's check where this is created. My Go environment is not really happy, so we will just find this the old way. I couldn't find a reference to this. You can see that in something in the called the scale handler. This is at the beginning of KEDA running based on the scalars that we have. It creates a scalar for each of the scalars that we have in KEDA. It creates it for also every time we are trying to get the metrics. At least this is what I believe. Looking at the code, every time we try to get the metrics or the get metrics for scaling, this method is invoked, and we construct a new scalar of that type. So this is why it's important that you manage your connections properly and close them if necessary and stuff like this. You can see that we have the list of constructors based on the scalars that we have. In our scalar, the one that we're gonna create next week, we will have something called like case, our scalar, which probably is gonna be something based on Twitter, case, Twitter, and we create our own new Twitter scalar. If we go back very fast, because we only have maybe like 8 minutes. Parse RabbitMQ data, because we received the metadata as a map of a string and a string. We need to make sure that whatever data that we have. Let me pin this one. And let's show here. This is the metadata that we have. We have numbers, we have strings. So we parse them, we make sure that they are right, and based on that we retain the metadata parsed, and we set it up in the scalar. Yeah, so we can finish this one. Git connection and channel. This is used within to create a channel. Close. This is where we close the connection. You can see that the guys who built the Rabbit scalar gave the right attention, and they are closing it. Awesome. Is active. If there's no messages at all, I think we retain false and becomes inactive. I don't think it will be pulled again if it's becomes disactive. Get queue messages. This is an internal method that is used within RabbitMQ to get the queue messages. We don't need to really have a look there. This is where we are constructing, like I said, we are constructing the horizontal pod autoscaler based on the information. So we are creating a metric name based on the trigger and the target average value. Now this is the bit I probably failed to explain. This is the last bit, and then maybe we go to sleep. the queue length. This is it. I think in your meta as a scalar, you provide something. You provide a value as a threshold to be used for how much containers per metric. So let's say in our example, if we go back here, let's say that for our queue, we are saying that for every 30 messages here, we are going to have one pod created. This means this number, we configure it in our scaled object to explain this. Now, if the queue became 60, the queue messages, or maybe 90, because we configured the scaled object to say this is the target value, I'm gonna have one pod per 30 messages, we will create another one based on these and another one based on these. So you'll have in the 90 you'll have 3 pods, in the 60 you'll have 2, in the 30 you have 1. This number is what we have in the queue length tag. What is the target average we are trying to achieve? Oops. So this is the target average value. We are comparing this with that. It's called target average value. In the metadata, it's called queue length. This is why I think this is one of the naming things that confused me a little bit when I was trying to explore. Maybe future ones should have queue length target value, target average value, queue length target average value. Too long. Anyway, this is the get metrics for scaling. Lastly, this is where we invoke the get metrics every polling period, and we get the messages. We see how many messages that we have. We create the external metrics value with the value, and we return it back. Now, the result is the external metric value, which is this. Yeah, the HPA will grab this, will compare it to the target average value, and we'll see that we have 60 retained. And in my configuration, it says I can serve. I need to scale, for example, per 10. Then it multiplies and says like, okay, I'm gonna scale by 6 containers. I'm gonna create 6 containers because every container has, or every pod can take 10. Let's say, for example. This is where we retain the metrics. I think this is a good point where we can stop. I will be streaming next Thursday to continue and create the custom scaler based on Twitter. I'll be very happy and honored if you come along and contribute and correct me if I make a wrong statement or even add value in any way you find suitable. I'll try to push this also on GitHub while we are developing. I think this is it for tonight. Thank you everyone who passed by, joined, heckled, or whatever. And see you next week.